Started today.
Yeah, love calculus. All right, limits. Let me give you a really short introduction to limits, and then we'll go through the problems that you have, okay? What is the limit of...
Sorry to interrupt, but do you have an hour or no?
No, I don't.
Okay, that's cool.
9 through 9 o'clock. I got some times tomorrow. I got
quite class tomorrow.
Yeah, here, let me open my calendar here. And the girl that keeps trying to text me is wanting to change her 4 o'clock. So I probably have a 4 o'clock, but I'm not positive. But any of the white space here, you see.
Okay.
I'll take a look at it later.
Tomorrow's Wednesday. Did you just send me your available times?
Can you see my calendar here?
Yeah.
Okay, I'm available from 3 to 4, from 5 to 5:30, and from 6 to 7, and from 8:30 to 9.
6 to 7.
Not just 6 or 7.
You have like you have brain balance.
No.
6 to 7 is good.
No, it's not.
Yes. Brain balance 7:30. 7:15.
You want an hour tomorrow?
No, just. Hey David, I will check it out right now to schedule, and I'll get back to you later tonight.
You can always go in and schedule it also.
Okay. We'll do that. Thank you so much, David.
I'm going to be in session for most of the rest of the evening, so it would be easier for you to go in and just schedule it, probably.
I will go ahead and do that. Thank you so much.
Okay, Leslie.
Have to begin with. Now we wasted like 5 minutes.
All right. Maybe our best way to go here is to just start. Where do these problems start? Do I just, if I keep scrolling down, will we get problems to do?
Yeah.
Where? Assignments 1 through 3. Where is that? I noticed that in the email there was this part down here. Is that different?
Yeah, it is.
I'm not sure it is. It looks like the same. Yeah, it's the same thing. So the question is, where are the problems? It's not that YouTube video. I know that.
Give me 1 sec. I'll be right back.
Okay. All right, here's some problems we can do.
David Zell, he'll be right back.
Okay. Yeah. I found some on the page that he had sent me.
Sorry about that.
All right. I have some problems here that I found some that they don't give the answers to.
Okay.
Let's look at them. First of all, the easiest way to find a limit is direct substitution. Okay? In other words, if you're trying to find the limit of x squared plus 6 as x goes to 3, just substitute. What do you get?
Wait, sorry? X squared, wouldn't that just be...
Trying to find a limit of a function, substitute.
Wouldn't that just be 15?
Correct. So that's easy. How about this one? What's the limit of 3x minus 2 as x goes to 5?
13.
Piece of cake, right?
Yeah.
Now we'll do a little harder ones. What's the limit of 1 over x as x goes to 0?
Is that undefined?
Yes, division by 0 is undefined, almost always. I should say, as long as you have a number in the numerator and you're dividing by 0, then the answer is undefined.
Mm-hmm.
If you have a situation where it's 0 over 0, for instance, this one, the second one there,
Mm-hmm.
notice that if you substitute 0, you get 0 over 0, right?
Okay.
All limit problems that are hard are of that format. Anything else is a piece of cake. If I have a number divided by 0, it's undefined. If I have 0 divided by a number, that limit is 0. You can have 0 in the numerator, you just can't have it in the denominator. Sometimes you can. This limit, we don't know what that is yet. Okay? So let's look at that function, 2x over x squared plus 3x. One way to solve the limits that are 0 over 0 is by factoring. Can I factor the bottom?
Would it be
Greatest common factor. What's the greatest common factor in the denominator?
x
What's left?
x and plus 3?
Okay. Now notice I can cancel those x's, and now I have 2 over x plus 3. Now what's that limit as x goes to 0?
2/3.
Yeah. So here's a case where it started out 0 over 0, and the only way we were able to solve it is by manipulating the function a little bit. And these manipulations can get hard. This is one of the easier ones. But you always want to simplify your function as a first step. And that usually involves factoring. Most all of the problems we'll probably talk about today involve factoring. However, let's talk about one-sided limits. Clearly, they're getting you in this immediately. Usually, they give you a couple days of limits before they talk about one-sided limits. One-sided limits mean it's a little easier to explain graphically.
It's given the address, I think it kind of was that. Given the address, I won't say it now, but it runs 6. Yeah, oh, it's right there. Yeah, it's over there by that liquor store, and it's right there.
You seeing this function?
Piecewise?
The one I just drew?
Is that piecewise?
Yes, that piecewise function. Okay, this is x. This is y. What's the limit of this function, which I don't know what the function is, but I can read the limit from the graph. As x approaches 2 from the right, which is designated like that. Look up at the graph, hop on the function, and start approaching 2 from the right. Where do you end up with on the y-axis?
You end up with 6.
So that's its limit. Okay? Now, what's the limit as I approach 2 from the left? In other words, what's the limit as x approaches 2 from the left side?
Would that be 6 again, or?
No, hop on the function. First of all, get to the left of 2. Hop on the function and start heading towards the point, like that. Where are we pointing towards? What y value are we pointing towards?
2.
Yeah. That's how one-sided limits work. You get left, for a left-sided limit, you get left, hop on the function, start going towards the number, figure out where your y value points to. Now I'm going to give you a particularly confusing one. There's a hole in this piecewise. As this function approaches 2 from the left, what is the limit?
3.
As it approaches 2 from the right, what is the limit?
Would it just be 3 again?
Yeah. What's the limit at 2? In other words, what is f of 2?
7.
Yeah. That's huge that you understood that right away. In other words, my limit is 3 from either side. And incidentally, a limit only exists if it's exactly the same from both directions. Okay?
Okay.
In other words, when I had the function looking like that, if I said, what's the limit at 2? In other words, what's the limit as x approaches 2?
7.
No, does not exist. Because the limit from the left is 3, the limit from the right is 7. Since they're not the same, it does not exist. Simple as that.
Okay.
That's your very first test. It has to be the same from the left as it is from the right for it to exist.
Or it doesn't exist. Okay.
Or it doesn't exist. Notice this function 1 over x. If I graph that, it looks like this. If I approach 0 from the left, what is my limit?
Does it not exist either?
Well, you might say negative infinity, right? I mean, if you hop on that function and you start aiming towards 0 on the x-axis, you end up heading towards infinity, negative infinity on the y-axis. So the limit from the left, as we approach 0 from the left, you could say is negative infinity, just if you read the chart. Okay? Can you still hear me? It looks like there may be an audio problem. Can you hear me? I'm going to call you on the phone. Yeah, hi Leslie. There's an audio problem with GoToMeeting, so I figured we could finish the audio by way of phone.
Yeah.
Okay.
Yeah, hold on. Here's Jacob. Hey.
Jacob, let's finish the audio portion of this using the phone, because my GoToMeeting is telling me there's an audio problem and I couldn't hear you. I don't think you could hear me. So,
Okay.
but phone works just fine. Okay. Back to this problem. If I approach 0 from the left, you can see that we're headed towards negative infinity. If I approach 0 from the right, where are we headed?
Positive infinity.
Yeah, since positive infinity is not the same as negative infinity, they are universes apart, right? Therefore, the limit at 0 as x approaches 0, that's why it does not exist. It's not so much that it's infinite, it's because it's not the same from the left as it is from the right. That's why it does not exist. If I had the following function, 1 over x squared, that function is y equal 1 over x squared. Now, what's the limit as I approach 0 from the left? What is it from the right? Same thing, right? So at the very minimum, I would say that exists. And I would say that that limit is infinity. In other words, I guess what I'm trying to say is that does not exist does not always mean exactly the same as infinity.
Oh, it's like the audio.
Yeah. I'll hang the phone up because if both are working, there's interference between the two. Can you hear me?
Yeah, it's repeating. Yeah.
Yeah. Okay. So anyway, that's just an interesting distinction between does not exist and infinity. Infinity is a legitimate answer to this problem. What is the limit of 1 over x squared as x goes to 0? Infinity. Your teacher might not like that answer, but I like it, and my calculus books like it. Okay? So, but some teachers will still say that that doesn't exist because I'm dividing by 0. All right, let's see. What else can we look at here? So let's look at this one problem here, one-sided limits. Okay? What's the limit as we approach 1 from the right? Which of these functions do you use, the top one or the bottom one?
Top.
So plug in 1. What's the limit from as we approach 1 from the right?
2.
Okay. And as we approach it from the left, we're going to use the bottom one, right? Because x is less than 1.
So negative 2.
Negative 2. Exactly. And what this would look like if I graphed it, well, there's my 1. Okay, so everything to the right of that has to look like x plus 1, which is a slope of 1, and so it looks like that. Everything to the left of it is x minus 3, so it's got to go through that with the same slope. So there's the two functions. And you can see that as we approach from the left, it's minus 2, assuming that's minus 2. And if we approach from the right, it's positive 2. So what's the limit as x goes to 1?
Two?
Does not exist.
Oh yeah, because there's no definite.
No, because the limit from the left is not the same as the limit from the right. That's the first rule that you have to have in order to have a limit at that number.
But if you get it like approaching from the right, then it would be 2, correct?
As long as approaching from the right gives you the same limit as approaching from the left, then the limit exists, and it's that number. Yes. Yes. In fact, if I don't make this a piecewise function, but just make it a function with a hole in it, like that, well now, the function as I approach from the left is minus 2. The function as I approach from the right is minus 2. So the limit exists, and the limit is minus 2, but notice that f of 2 does not exist, because there's a hole there. So f of 2 does not exist. Yet the limit does. The limit as x approaches 1
Let's get around with that.
Which is equal to minus 2. Still there? Can you hear me? Really? I will call again. All right. In your GoToMeeting, turn it to phone call. In other words, go up to the audio tab and make it say